Hello children, welcome back. So today we are going to take up another topic, which is uniform circular motion. Now what is this uniform circular motion? How do we define it? Now if you look at the definition which is written, if a body is traveling equal distances in equal intervals of time in a circular path, and the condition is the speed of the body is remaining constant or uniform, then we say that the body has got a uniform circular motion. So when a body is moving in a circular path, so this is a circular path, we have taken a body, let us say these are the positions of the body. Now this body is moving in anti-clockwise direction. Now, why do we call it as circular motion? Because this body is moving in a circular path about the center. This is the center of the circular path. Let us say this is the radius r, and the body is moving in a circular path. And when it is moving, the speed is remaining constant. So we have a body moving in a circular path with a constant speed. But whenever the body is moving in a circular path, let us try to analyze the situation now. To understand this, let us take a few cases. Like if we have a rectangular field, we have got a rectangular field. Let us say these are the vertices of the rectangular field, and the athlete wants to run along this path. So if the athlete is running from A to B, then B to C, and C to D, and then D to A, the athlete has to change the direction every time he reaches the vertices. So the athlete changes his direction at A, B, C and D. So if he starts from A, then he moves till B. So here he changes its direction once. Then he reaches point C. Second time he changes his direction. He reaches D. Here he changes the direction third time. And again when he reaches to point A and then turns, he will change the direction 4 times. Now if we have got a pentagon, something like this, and the athlete is running from A to B, B to C, C to D, D to E, he has to change the direction every time he reaches these vertices. So here, then here, then here, then here, and then here. Now if we have a hexagonal field, in this condition, again he has to change the direction at these vertices. So what do we find? We find that if we keep on increasing the number of sides in a polygon, the person is changing the direction according to the number of sides. Now if we compare these polygons with a circle, how many times would the athlete change the direction if the person is moving in the circular path? Imagine yourself to be running in a circular path, and the question here is, if you are running along a circular path, how many times would you change your direction? you would change your direction how many times? Infinite times. So, in a circular path, the body changes the direction infinite number of times. So when a body is moving in a circular path, when a body moves in a circular path, the direction keeps changing continuously. So, if we talk about the circular path here, the body is moving in a circular path. The speed of the body is remaining constant. So, speed remaining constant. Speed of the body always remains constant because it is uniform circular motion. But what about the direction? The direction is continuously changing. So the question is, what is the direction of the body? So let us try to discuss about the direction in which the body would be tending to move when it is moving in a circular path. Now if you look at this, we have got a circular path. Let us take, imagine that the body is moving, body is here. And we take the direction, let us say this is the anti-clockwise movement. Now we are more interested in knowing what is the direction of the body at point A. Now at A, the speed is constant, but let us say that we have tied this with a thread and the thread breaks. If the thread gets snapped, in which direction is the body going to move? If the thread suddenly breaks, we break the thread, you would find that the body is going to move in this direction, which has been shown here. This would be the direction in which the body is going to move. Let us say this is AX. Now this direction is, or we can say AX is the tangent at A. AX is the tangent at point A. Now what is a tangent? A tangent is a line which touches the circle at one point. Now this tangent is a new word for you. So a tangent is a line which touches the circle at one point. You know about a chord. A chord will touch the circle at 2 points, but a tangent is going to touch the circle at only one point. So at point A, the direction of the body is towards AX. Now if the body reaches here, if this is the point now, what would be the direction of the body? The direction of the body would be again tangential. So this would be the tangent now. At B, the direction of the body is towards BY. If the body is here, the body would have a direction. Let us say this is point C, the direction would be towards CZ. So at every point, if the body is here, the direction is this way. If the body is here, the direction is tangential. This is the direction. If the body is here, the direction of the body is towards the tangent. So when the body is moving in a circular path, the speed remains constant every time. We have written the speed remaining constant. The direction keeps changing continuously. And what is the direction in which the body is moving? The direction of the body, is always tangential. So in this path, when the body is moving in a circular path, the speed remains constant, the direction keeps changing continuously. Now if we want to simplify it, we can say the speed of the body at point A is towards AX. So we can write speed of the body at point A is towards AX, because the motion is this side. Speed of body at point B is towards BY. So we can we say that the velocity is changing because the direction of the body is changing. We can say speed remaining constant, velocity of the body changes. So whenever the body is moving in a circular path, speed is constant, direction keeps changing, and because of the changing in direction continuously, we are getting the velocity of the body now, and the velocity of the body is continuously changing at all the points in the circle. And if there is a change in velocity, we can say that the body has got acceleration now. So a body in circular path, moving in a circular path, in spite of having a constant speed, would have a changing velocity, and because of the changing velocity, there would be acceleration in the circular path, and therefore we say the circular motion of a body is accelerated motion. Okay, so circular motion is accelerated. Circular motion is accelerated. Why it is accelerated? It is because the velocity changes. And why is the velocity changing? The velocity is changing because the direction of the body is changing continuously. And what is the direction of the body? The direction of the body is always tangential to the circle. Okay, so in circular path, whenever we talk about a circular path, we always say that circular motion is accelerated motion. Why is it accelerated? This question comes in the examination. Why is circular motion called accelerated motion? Now why is circular motion called accelerated motion? Because the direction is changing, speed remaining constant, and what is the direction? It is always tangential, and because the direction of the body is changing, velocity also changes, and because velocity changes, speed of the acceleration of the body also exists. We cannot say that acceleration is zero. Okay. Now how to calculate the speed of the body here? Speed of the body would be equal to circumference divided by time. And what is the circumference here? If we take r as the radius of the circle, if r is the radius of the circle, it would be 2 pi r by t. So magnitude of velocity, in this case, always remember, magnitude of velocity is always constant. Magnitude is always constant, but what about the direction? Direction keeps changing. These are the 2 points you have to remember always. Direction of the body keeps changing. Okay, so this is all about circular motion, and you can find out the speed of the body by using the formula 2 pi r by t. It's a very easy formula to remember. Okay, thank you very much.